Good evening to all of you. Hello, I am Saikat Giri, Chemistry faculty of IIT JEE and NEET. I have experience of nurturing approximately 200 students in IIT JEE and NEET. I was an ex-faculty of Sri Chaitanya, Narayana and Alan Kota. Now I am working with Akash Institute. Today we are going to read about one of the most important part of chemistry, that is chemical bonding. In chemical bonding, specifically we will read about VBT. Before moving to VBT, we have to know what bonding is. What do we mean by bond? Bond means, let us consider, we are taking two elements. They have a specific amount of energy. If we consider their energy is E1 and E2, they combine with each other and they form a new compound that is considered as AB. If we take A2 and B2, these are two molecules, they combine with each other, they forms 2AB. If I consider their energy is E3, then obviously E3 will be less than E1 plus E2. Why? Because the motive of chemical bonding is to gain stability. In chemistry, whenever we are making any bond, our target is to decrease energy. As we know, energy is proportional to 1 by stability. So in chemical bonding, we read about many type of bonds. Among them, covalent bond, ionic bond, coordinate bond, metallic bond, hydrogen bond, several types are discussed. Today we are going to read about one of the most important concept, that is VBT. In VBT, there are two scientists, Hetzler and London. They have explained the concept how covalent bond is formed. So, coming to the concept. So, our topic is VBT, that is valence bond theory. In valence bond theory, there are two scientists who has explained overlapping theory. So coming to the division of it, its division is two. First one is overlapping theory. And another concept is hybridization. So, overlapping theory, what are the postulates of it? Overlapping theory. This concept is explained by Hetzler and London. What they have told? They have told if we take two half-filled orbitals, we know one orbital can accommodate maximum 2 electrons. So if we take two half-filled orbitals and they are having opposite spin, then they will combine with each other and form a covalent bond where 2 electrons are arranged in such a way so that they have opposite spin. This type of spin is known as spin paired, and this bond is covalent bond. So to explain covalent bond, Hetzler and London has given overlapping theory. It was the first approach to make covalent bond. So when we are discussing about covalent bond, what is going to happen here? We are going to discuss it. For example, I am taking hydrogen and chlorine. In case of hydrogen, there is 1 electron in its outermost orbit. In case of chlorine, there are 7 electrons. So what is happening over here? It is taking 8 electron, and in this case hydrogen is filling up its duplet. Now form H bond Cl. This is mutual sharing of electron. So in case of covalent bond, there is mutual sharing of electron happens. So what are the postulates of this theory? First postulate is we are going to take two half-filled orbital to form covalent bond. Second postulate is, if we are taking two electrons, it is mandatory that they are arranged in an opposite direction, so that one is considered as plus half, another is considered as minus half. So one more concept, one more important part of this overlapping theory is, whenever overlapping is happening, it is mandatory that orbitals should have directional character. So the first confusion comes, what do we mean by this directional character? What directional character is? Let us consider, we are taking S subshell. We have a common confusion that we tell SPDF orbital. It is not orbital actually. S is a subshell. Inside S subshell, this box is considered as orbital. If we take P subshell, in this P is a subshell. Here, three boxes are there. Each box is considered as orbital. This is an orbital. This is also a orbital. This is also a orbital. It is named as Px, Py and Pz. So the concept is, whenever overlapping is happening, it is better that that subshell should have directional character. So what do we mean by directional character? We know that S is in 3D spherical in shape. In 2D it is considered as circular. So we know that circle has no direction. So S subshell having non-directional character. It is having non-directional character. So coming to P subshell. P has directional character. As we can see, it has Px, Py, Pz orbital. So if I want to draw Px, it will be like this. Px, if I consider in this axis is x, this is y, then Px can be drawn like this. So it has a certain direction. So we can say it has directional character. So Px orbital having directional character. Py also having directional character, also Pz having directional character. In case of d orbital also, that is represented as dxy, dyz, dzx, dx square minus y square and dz square. It is also having directional character. So the concept is, if overlapping is happening in between two directional subshells, then it will be a better overlapping. For example, if we are taking P, another P, among them, if overlapping is happening, it will be named as, this is P overlapping. So we can say the extent of overlapping is very good in case of PP, because both are having directional characters. But if we take both SS orbital, in this case, what is happening? Two orbitals are there. They are having SS overlapping. So in this case, both the S orbital are sharing their area and they are overlapping with each other. But they do not have any directional character. So the extent of overlapping in SS orbital will be very less. If we take P, these are both P. If we take P with S, in this case also overlapping will be good, but not very good like PP. So if I compare all these three, in between SS, PP and SP, the order will be, SS will have least extent, SP will have greater extent, and PP will have best extent of overlapping. So the concept of extent of overlapping is completely depending on the directional character. So in overlapping concept, we also follow one more concept, that is, if the value of n is increasing, in that case bond strength will decrease. Value of n is increasing means, let us consider, I am taking 1s to p, I am taking 2s to p, and I am taking I am taking 3s and 2p. What is going to happen in this case? 3s and 2p. In this case, extent of overlapping will be highest here, because in this case all three are s and p orbital. As it is more nearer to the nucleus, so extent of overlapping will be better in this case. We are going to the next concept. So depending on these extent of overlapping, two type of bonds can be formed. One is considered as sigma bond, another one is considered as pi bond. So how sigma bond is formed? If there is head-on overlapping like this, if this type of overlapping is happening, head-on overlapping is happening, then there is a chance of formation of sigma bond. In this case, sigma bond is formed. In this case also sigma bond is formed. In this case also sigma bond is formed. So the question is, when pi bond will be formed? Pi bond will be formed for these type of cases. If I take like this, so they are, you can say, sidewise overlapping or parallel overlapping like this. If orbital overlap like this, in this case, their pi bond formation may happen. So we can draw like this. So in this case, formation of pi bond is there. In this case, sigma bond is formed. Here also sigma bond is formed. So this is the concept of VBT. But VBT has some mistakes. So we need a new theory that is known as hybridization concept. So we are going to the next concept that is named as hybridization. So what is hybridization? Hybridization simply explains intermixing of orbital. Intermixing of orbitals. Now, first question comes in mind, what is the difference between overlapping and intermixing? What is overlapping? What is intermixing? How can we say what is overlapping and what is intermixing? Overlapping means if we are taking two orbitals, their area is being shared. Both the character of the two orbitals remains as it is, means no loss of character. But whenever we are intermixing the orbitals, in that case, let us consider I am mixing s with p orbital. Here a new character will be formed that is named as sp. So here two sp orbital are formed, that is intermixed orbital. If we do overlapping between s and p, so formed is, so this is formed. In this case, both share their area and the character remains as it is. So this is the basic difference between intermixing and overlapping. So in case of hybridization, what is the importance of it? First question comes that why hybridization came? Why hybridization? What is the importance of it? Let's answer this question. Let us take an example of CH4, methane. We know that whenever we draw methane, the bonds are like this, CH4. So we can say all the bonds of methane are identical. So according to the concept, according to the modern concept of valency, what is valency? Valency is number of unpaired electron present. Unpaired electron present, that is considered as valency. According to the old concept, combining capacity of an element is called valency, but the new concept tells that number of unpaired electron is valency. Let's check out. So in case of carbon, atomic number is 6, configuration 1s2, 2s2, 2p2 in its ground state. So if we draw it, it is 2s2 2p2. So it is having only two unpaired electrons. So according to the old concept, combining capacity of element, that is valence, but modern concept, number of unpaired electrons. So here are two unpaired electrons. So valency should be 2, but we know that carbon has valency 4. How is it possible? So carbon do not react in its ground state. It always react in its excited state. What happens? One electron of 2s orbital moves to 2p orbital. So there are total 4 unpaired electrons. So valency of carbon is equal to 4. So what is the logic behind telling this? Let's check out. In case of CH4, whenever we are writing about carbon, it is 2s1 2p3 now. So in the valence cell we are having one electron, that is s, and in case of p there are 3 electrons. So if we draw its shape, this is s, so 3p are there, 3p we have drawn. In case of hydrogen, we have 4 hydrogen atom total. This is for carbon. 4 hydrogen atom, all are having s orbitals. Now I am combining both. Let's check out. Here s combines with s, so one is ss. In these three there will be s combining with p, s combining with p, s combining with p. So there is 3 sp orbital. Here is ss orbital. So according to the concept of VBT, this bond is different from these 3 bonds. But we know that in case of CH4, we draw the structure like this. All 4 bonds are identical. So this is the main mistake of VBT that is being improved in hybridization concept. So in hybridization, we came to know about that all 4 bonds, they are identical to each other. So let's take hybridization concept. So while finding out hybridization, we follow VSEPR theory. That is valence cell electron pair repulsion theory. So from VSEPR theory we came to know about hybridization. What is VSEPR theory? In VSEPR theory it is explained that we put 2 atoms in maximum distance to nullify the repulsion in between them and to make them stable. The second postulate is told, if all atoms are in its position and no lone pair came, there will be no distortion, there will be no change in the structure. Structure will remain according to the steric number. What is steric number? I am coming to that. And the third concept is told, lone pair repulsion, lone pair repulsion is greater than lone pair bond pair repulsion greater than bond pair repulsion. For entry of each lone pair, angle decreased by 2.5 degree. And finally, in VSEPR theory, one technique is given to find out the hybridization of any element. That is, so hybridization is equal to valency of central atom minus number of monovalent atom, it is added, plus if negative charge minus if positive charge, all divided by 2. It is the way to find out hybridization of element. Now let's see the rule of steric numbers. Steric number That is, if steric number is 2, what will be the hybridization? Hybridization is SP. How it looks like? It looks like this. And what is the angle? It is 180 degree. So the shape or geometry, we can say it is linear. We are considering when lone pair is not present, then shape is equal to geometry. If lone pair comes, then shape and geometry will be different. Geometry will not change, but shape will change. Now, if we take 3, it will be sp2. Shape will be like this, and geometry will be also. Angle is 120 degree. This is known as trigonal planar. If we take 4, it is sp3. It is considered as tetrahedral. This is tetrahedral. Angle is 109 degree 28 minutes. If 5, it is sp3d. This is the geometry considered as TBP, trigonal bipyramidal. If we add like this, we can see two pyramids. One pyramid, another pyramid is this. So TBP, trigonal bipyramidal. Angle is 90 degree and 120 degree. Here, these two lengths are considered as longer with respect to these equatorial positions. So here axial length is greater than equatorial length, and most electronegative elements are put in the axial positions. If 6, it is considered as sp3 d2, and it has the shape like this. This is considered as octahedral. Angle is 90 degree. And if we take 7, it is sp3 d3. Its geometry is considered as PBP, pentagonal bipyramidal. It is pentagonal bipyramidal, PBP. Here angle is 90 degree or 72 degree. So this case is when there is no lone pair of electron. Now let us take few examples and we'll see what changes are happening if lone pair enters. If we take the example of CCl4, we are going to apply the rule. Carbon valency is 4, so valency of central atom, plus chlorine is monovalent atom, number of monovalent atom 4 divided by 2 means 4, that is sp3. So it looks like CCl4. It is having tetrahedral geometry. Now, if I take any anion, for example, SO4 2 minus is given. Sulfur oxidation state 6 plus. Negative charge is there, so plus 2. Oxygen is divalent, so we are not going to take the value of it. Divided by 2, 4, that is sp3. How it looks like? Sulfur, O4 2 minus, double bond O, single bond O minus, single bond O minus, double bond O. So this is the structure of SO4 2 minus. If we take any positive charge, for example, NH4 plus, what is going to happen? So nitrogen 5 plus 4 monovalent atom 4 plus is there, so minus 1 divided by 2, that is equal to 4. So it is sp3. In case of NH4 plus, the shape is going to be like this. Now, if we take PCl5, in this case central atom is phosphorus. Valency is 5. 5 chlorine atoms plus 5 by 2. So 5, that is sp3d. We will write like central atom is phosphorus, 5 chlorine atoms are there. So this is the structure that is considered as TBP, trigonal bipyramidal geometry. Now let us consider one lone pair comes. Now what is going to be the shape? For any compound, let us consider one lone pair is coming. So if we take any lone pair is present, 1, 2, 3, 4. So this position lone pair will come. This is considered as seashore. So when lone pair came, sp3d hybridization, TBP geometry, shape will be seashore. If two lone pair comes, let us consider two lone pair is coming. So here two lone pairs are present. So it is considered as bent T-shaped. Let us consider three lone pair is coming. So these three lone pairs, first, second, third. This will be linear. This is the variation in case of sp3d. If we take SF6, in this case 6 plus 6, 12 divided by 2 equal to 6, it is sp3, 1 plus 3, 4 and 2, 6. This will be SF6. SF6. Now, if in this case one lone pair comes, what is going to happen? Shape is going to change like this. If one lone pair is present, so this is going to be the shape. If two lone pair is present, it is going to be the shape. So this is now square planar. This is square pyramidal. The previous we have it is considered as square bipyramidal. That is SF6 has shape that is square bipyramidal. This is square bipyramidal or octahedral. Now, if we take for this shape, that is PBP, pentagonal bipyramidal. Let us consider I am taking IF7. So 7 plus 7, 14 by 2. 14 by 2 it is coming 7 sp3d. Now iodine is the central atom. 5 fluorine are present in this position and 2 more fluorines are left. So IF7. Now for this case, if one lone pair comes, if in this case one lone pair comes, this will be pentagonal pyramidal. If two lone pair comes, this will be pentagonal planar. One most famous question, that is, if they give you like this I3 minus, what is going to happen? So central atom is one iodine, maximum valence 7, plus rest 2 are side atoms and iodine is monovalent, plus 2, 9 for minus 1 divided by 2. So this is going to be 5. sp3d. How can I draw? It will be drawn like this: I3 minus, in this case, 1 lone pair, 2 lone pair, 3 lone pair. By this way, we can find out the hybridization and shape and geometry of different type of structures. Thank you everyone. Thank you for listening. Have a good day.